Ciao! Today I want to follow up on the previous video about using OCI Artifact as a technology and infrastructure for machine learning model assets and their metadata, and specifically I want to focus on the ModelCar aspect. So we are in the previous video we've seen that we moved in a workflow that set up first an OCI artifact and then we wrapped that in a ModelCar. So today we are going to stay mainly in this pillar, but with some demos. So if you haven't seen the previous video, I totally invite you to check out that one first. I'm going to send the link somewhere. And then finally in today's video we're going to focus on 3 demos. First is using the ModelCar in a traditional KServe setup. So this is just the context. Then we're going to move to C into using a ModelCar with a KServe Raw, just to showcase that the technology can actually be composed in several different type of KServe environment. And finally, we're going to iterate again on the power of composition for this underlying infrastructure. And we're going to see how we could evaluate to use the OCI artifact directly in KServe by defining a custom storage initializer. So with that, let's dive into the demo. Alright, so in the previous demo video, we've seen that we had a machine learning model and we wrapped that as an OCI artifact and we then wrapped that as a ModelCar. So just as a recap, let's say that we want to interact a little bit first locally here with the machine learning model so that we can make a better sense of the data that later we are going to interact with as we move to using this machine learning model in a ModelCar on KServe. So my test data, so let's say that I had input at IDX was the X for the test data at the IDX and we're going to reshape it for 1 and -1 for convenience, and then the prediction for that at IDX is going to be using the machine learning model to predict using the at IDX, and the test IDX was actually, just to make a comparison, is going to be Y for test at IDX. So we can print this one, we can print it IDX, we can print the actual prediction and the actual test prediction. So of course we have no guarantee that the trained machine learning model, given the test data and reiterating on them, will exactly predict the same values, but in this case it's quite so accurate that I'm using that just for the convenience of the demo. So in this case we can see that given some input values we receive a prediction class number 2, and this is the one that is same for the test. So let's say with another index, so we see that giving it some other features values, we can see the actual prediction and what was the test data prediction. And finally we can do it also for IDX4. So again we see these are the inputs for my model, and this is the class prediction that the model when exercised gives me, and this was the one from the test data. So again, I have no 100% guarantee that this is the behavior between the actual prediction and what was the test data, but just for the scope of this demo, this is the way that we expect the model to behave. So given some prediction, we can see what was the input, and we are going to use this test data later. Now, what I have here is a KServe cluster that I prepared as the best cooking show. I prepared it on the side, and I just followed the instruction for the KServe. So I followed this instruction guide that is very helpful for convenience of development in a local environment, and then I followed the user guide for the actual ModelCar by enabling ModelCar, so by following this instruction. And this is already available in my Kubernetes cluster. So now let's move in to see how we can use the ModelCar. As we remember what we did in the previous video, we went from wrapping it first, the machine learning model asset and the metadata as an OCI artifact, and then we wrapped that in a ModelCar. So at this OCI registry reference, v1 model car, I have an OCI image that contains, in a Hall effect, my machine learning model. So what I can do is that I can define an inference service. So these are the primitive of the KServe. And as we can see, we are pointing that to ModelCar. So let's see that in action. We can take this, all of this, and we can go and ask KServe or proper, actually my Kubernetes, to deploy. So let's go to the default, and then we can say, okay, please deploy that for me. All right, so as we can see, it has now been fully deployed. So I can even go here to my deployments at the time that it refreshes. So as we can see now, this has been deployed. And then how to interact with this in my KServe. So just as a reminder, we can follow the instructions that are here. Since I'm using a local development, then I will need first in a terminal, I need to port forward on the Istio. So this is what is showing here. And then we can follow here the same instruction of performing inference. I have already some commands that we can exercise. So I have here some command that we can exercise. So once I port forwarded on the Istio, I can prepare for me the name of the service. So we can even echo the service name. Okay, so this is indeed as we expect. This was the one that has been created. And now if I go to do this call, then I'm sending some input 0. We can go and see what is this input 0 in data, input 0. We can actually preload here on the side some of them. And as we can see, it has predicted that the class value is 2. As you remember that I shown to you first locally. So we can even go and see for input 1. So we can go here and we can ask, okay, give me the class prediction for this set of values, and this is the same class prediction. Then we can do the same exercise as well for input 4. And as you can see, it is predicting, okay, the same value. Again, we don't have the 100% guarantee given those are stochastic model, but then this proof on the demo that is working as expected. So what just happened is that in my KServe cluster, I've used a ModelCar. So my KServe enabled with the ModelCar. And then I've asked, please create for me an inference service with this name that is pointing, that is pointing at this OCI reference using ModelCar. So this concludes the first demo. Now we can move and see the same concept now applied in a KServe Raw environment. Right, so in this second demo, we are going to see the use of ModelCar, but in a KServe Raw environment. I've already prepared a KServe Raw environment here locally, and I followed this instruction. And also I want to remind you that I followed the instruction to enable the ModelCar as we seen previously. So this is my Kubernetes cluster right now. And now I can use again the ModelCar, but now in this KServe Raw environment. So if I go here, what I want to do is that again, I want to take this manifest and I want to deploy it. So let's say that we go to the default, and here we can say, okay, do this one for me. So the time that it will make it available, right? So this has now become available. So what I can do now is interact in exactly in the same way. So the only difference here is that since we are in a KServe Raw, what I need to do is to prepare some port forward. And in this case, I'm port forwarding directly to the predictor service. So this is needed because we are in a KServe Raw, and in a KServe Raw, we don't necessarily use the Istio. So in this case, what I want to do, however, again, is doing the same exercise. So let's say that in a terminal, then these are the ingress host and ingress port that I want to use, and I can do similar exercise as we did earlier. So I can go here, and with no big surprise, we can see that it is predicting again the same class for given some inputs. So here is with the input 1, and we can see as well for input 4 is predicting this value. So up to here, no big surprises. Everything is working as we expect for our input data and the predicted class values. The only difference is that it behaves the same, but behind the scene it is using a KServe Raw and again a ModelCar. So this was the second demo. Now in this scenario, but it will work analogously in a full KServe deployment, we can see the power of decomposition and move into a third demo to actually use directly the OCI artifact. To see the third demo in action, I want to point out in the user guide under model storage, you can define your own custom storage initializer. And in this case, the guide offers you a way that you can customize. What we prepared here with Andrea is a custom storage initializer that works with the OCI artifact, and behind the scene actually is using the Horace library. So the way that this one works is that you can define your own custom protocol. In this case, with Notch Math Fantasy, we decided to use OCI-artifact since the OCI column / was already used by ModelCar. And I think that also this one as well provide more specificity to the protocol. Now, what we need to do is that we can just directly define that one in our Kubernetes cluster. So I can kubectl apply that file that is called OCI Artifact. Right. So what this one is doing is that is giving KServe the needed pointers on how to handle a protocol that would work as OCI artifact column //. So these are the one that I prepared on the side here, and it's a very similar manifest if compared to the one that we used at the very beginning. As you can see, it is very close, but instead of using the ModelCar, is using directly the OCI artifact coordinate. Just as a reminder, in our OCI repository, what we have is that the ModelCar wrapped the OCI artifact that contains just the model asset, and its metadata. So what I can do now is that I can directly kubectl apply, and I want to apply the one that is called ISVC OCI artifact. So what this is now doing in my Kubernetes cluster is that is giving a provisioning of a predictor service for the same model, but directly using the OCI artifact. Okay, so it became available, and now we can interact almost the same. The only difference is that instead of port forwarding to the previous predictor service, now we need to directly reach the one that we just created. So not this one, but I need to port forward on the my inference OCI artifact predictor, which is this one that we just created. And what we are going to expect here is that it would behave the same as we did for the original. So yeah, so why this is giving me an error? Because the model name, actually I need to make myself a bit smaller. I can show you here what is the error. This the good things of doing demos live is that I'm using the wrong name. So at the localhost 8080, what I have is not that model name, but it's called my inference service OCI artifact, because this is the one that indeed we had just created. So if I go here just to show you, okay, it's predicting again the expected values. Again, there is no 1% guarantee that is the same class prediction, but for the purpose of the demo is working as intended. And I can do it also for input 4. Input 4 was this set of input values, and this is the class prediction, which is the one that we expect. And this concludes for the third demo, where we define what we did here is that we defined a custom storage initializer. And what we did is that this custom storage initializer can take OCI reference, which are in all effect OCI artifact. And what this one is doing is that then I can create directly an inference service that will take my OCI artifact coordinates that in my case are the ones that are here. And then the KServe machinery would automatically provide the services that I need. So in conclusion, what we've seen today, we've seen a spotlight on the ModelCar as a follow-up of the previous video. We've seen how we gone from a machine learning model asset and its metadata, we wrapped it as an OCI artifact, and then we provided the ModelCar. Then we use the ModelCar in a standard KServe deployment environment, and so basically all the prediction that we did first locally within the model, then we can do it through the KServe Open Inference Protocol. Then we actually seen the power of composition that this underlying OCI infrastructure enable us to do. So we seen, for instance, that ModelCar works as well the same in a KServe Raw environment, and then we seen that one in action too. Then finally, we can see the power of composition just going a bit in the opposite direction, and we destructured the ModelCar just to take again the OCI artifact. So what we did is that in a KServe Raw environment in this case, but it will have worked analogously as well in a KServe standard environment, we defined a custom storage initializer that is able to speak the language of OCI artifact directly. And this custom storage initializer, what it does is that it can take an OCI reference that is in fact our original OCI artifact. And then we've used the same model. As we expected, the interaction that went with the machine learning model from my local environment, then in a ModelCar that is provisioning the model for the KServe, or using a custom storage initializer that helps the KServe to provision this machine learning model, is exactly analogous. And what we've seen is that thanks to the KServe Open Inference Protocol, we were able to make prediction of the machine learning model that is now deployed in a Kubernetes environment for scalability and in order to use all the cloud native capabilities that a KServe environment on top of Kubernetes would provide. I hope that these demos were interesting and helpful to also play a bit with all this concept, and maybe you will find a way to apply for your situation. I will be very happy to hear your feedback. You can leave it down below, and as always, I will see you at the next one. Ciao!